got a series in this story map, which is an interactive way of presenting data. We'll talk about how your students can actually create story maps just like I have for this webinar today going forward. But I've got a series of 10 or 11 ways to teach with these tools that I've hand selected. There's a lot more we could talk about, and maybe as Brianna and I were talking about, if there's interest out there, let CAEE know. Hey, we want level 2. We want a deeper dive, and I can certainly provide. Okay, but as I touched on a moment ago, interactive mapping tools on the web, nothing to install. Many of them require no login or sign in. You can actually use them when the students are arriving in your Zoom session in the next 5 minutes, or the bell's going to ring or something like that. You can pull these up and then start teaching with them. In the same way as in the not too distant past, and I still love paper maps, as you might imagine, me working at the USGS, I've got a whole office load of paper thematic and topographic maps, and I truly love those. But any educator could take, for example, this dynamic planet map from the USGS, that big wall map with the earthquake locations, the plate boundaries, and the rate of plate movement, and volcanoes are also on there, and teach with it. You don't need a whole big lesson plan. You could teach with that map. The disadvantages of that map, though, are that it's large. You've got to have it face-to-face. Sure, there's a digital version, but it's static. It was produced in the mid-1980s, which is probably before Brianna and many of you were born. Anyway, the point is, those are great resources, but they're static. You can't add data to them, and they're locked in the scale. You can't zoom in. You can't look at last week's earthquakes, etc. But these interactive mapping tools, you have a lot more power at your fingertips. Adding data, adding real-time data, zooming and panning, etc. Okay? So, yeah. So, folks, sorry about the audio. Sorry about that. Anyway, the point is, let's dig into a couple of these tools. One of them, which I find very compelling, is something called the Indicators of Planet Earth. The Indicators of Planet Earth. This was created with a tool called the Experience Builder, which you also have at your fingertips. And this Indicators of Planet Earth allows you to do things like this. I'm going to take these tiles, and each tile is about a certain. Think of this as kind of like a nervous system of planet Earth. Each one of these tiles gives you a little snapshot of what's going on right now with drought, with wildfires, with Arctic sea ice, etc. And so you can go to any one of these indicators and say, you know what, I want to look at wildfire right now. Okay, I would use this in the following way. And there's other things we could talk about, other ways that you folks would probably want to use this. But let's say we just went to wildfire. Okay, well, in wildfire, for example, I've got real-time wildfire perimeters on an interactive web map. So let's say every Monday you go to the Indicators of Planet Earth and you have the students, either you guiding them or you say, okay, which team wants to investigate Arctic sea ice this week, or today's class, or tomorrow's class. So every week you could pick a different one, or you could assign a group of students to different indicators. But let's say just in this wildfires one, we're looking at the perimeters of near real-time wildfires, and the map starts at Brazil, but as you can see, it's all interactive. And so I can say, oh, I'm going to pan over to California, or I'm going to pan over to Colorado and look at the perimeters there. I'm not stuck with the default where these interactive maps are located. So the point is, what's wildfires? Why do wildfires matter? How are they in close proximity to human settlement? And it comes down to me, three things. What's where, why is it there, and why should we care, right? What's where, why is it there, and why should we care? So every one of these indicators has an interactive set of maps that you can interact with, click on, for example, wildfire perimeters, and pop up what's going on at that particular location, and if it was human set, or was it a natural event, etc., or a combination of those things. So the Living Atlas indicators, I think, is a good starting point for this, sort of like a nervous system of planet Earth. Just like your body has a nervous system that regulates all your vital organs, right, without which we wouldn't be having this conversation. The indicators are sort of what's the status of planet Earth right now. And they're all tied to these interactive web maps, almost all of which There's no login required, and they're all powered by the same system, which is called ArcGIS, which is the kind of, it's our own brand, Esri's brand of GIS. And there's some geeky story behind why it's called ArcGIS that I can share if you're really interested. But it's kind of like McDonald's. McDonald's, everything starts with McSomething. And in Esri GIS land, most everything comes from, it starts with ArcGIS. So yeah, good question there, Sarah. I've got some elements here in the webinar today about where does the data come from? How do I know if I can trust it? How often is it updated? What scale is it created at? Which I think are very pertinent questions to ask. So these, the Living Atlas indicators, every one of them has metadata. I never metadata I didn't like. Well, that was a little geo pun. Anyway, the point is you've got to encourage the students, and you as well, to ask those questions and to look at the metadata saying, okay, does this data meet my needs? More about that in a bit as we go through the webinar. But yes, absolutely. I want students, because these tools are so data rich, I want them to always ask the questions about where did it come from and can I trust it? There's so many maps out there nowadays, right? And remember, this is an open platform, so you and your students can create content in this same platform, and there's no Esri guard at the door saying you cannot put that data there. It's a completely open platform. So it comes from a variety of different sources. This Living Atlas of the World is a subset of ArcGIS.com. ArcGIS.com has millions in the M of maps and data layers. The Living Atlas of the World is a subset of ArcGIS.com, and it contains authoritative data from NASA, NOAA, U.S. Census Bureau, United Nations Environment Program, the CDC, State of Colorado DNR, etc. Does it mean it's perfect? No. We have a dynamic planet. We've got an oblate spheroid. We're trying to cast that data onto a 2D or a 3D map. So we have all kinds of map projection issues, missing data, but that data in the Living Atlas is all documented with rich metadata. So you know who created it and how often it was updated, and all those other things that I talked about. So it gives you a little bit more confidence that, okay, it's not perfect, but it's the go-to first stop. It's the go-to first stop that I always use when I'm teaching. So let's dig a little deeper now, and let's look at a couple of variables in what I call the water balance app. This is another tool that I think is a nice introduction to why we should care about water issues. And so I'm going to close a couple of tabs here just for sanity. Okay, so let's go to the water balance app. And again, you've got this story map. I've got it in the chat box if you came in a little bit late, and you have access to this as well. So I'm going to go ahead and open the water balance app. This has 6 variables in it. It's not real time, as we'll see. It's about 3 months old. But even so, it gives you a nice spatial and temporal ability to analyze what's changed and what the water situation is with evapotranspiration, precipitation, soil moisture, etc. Awesome. Thanks, Janelle, for sharing. So in the water balance app, I've got some variables at the left side. Again, no login required. You can see the URL is livingatlas.arcgis.com, so it comes from that subset library that I talked about with the 8,500-ish data layers. I'm going to change it from soil moisture to, let's change it to precipitation, and then I'm going to pan down to Brazil. And I always like to think about mapping as it sometimes confirms your preconceived notion of how the world works, and sometimes it shatters your preconceived notion of how the world works, right? So ask the students, okay, if I click in the Amazon, what do you think the precipitation is going to be like? And hopefully they'll say something, well, based on our discussion over the last few days about ecoregions around the world and tropical ecoregions, including the Amazon, I'm not going to see a summer-winter season and a dry season, which is exactly what we have here, right? If I pan my mouse across this graph, first of all, it fosters numeracy as well as graphicacy, right? It fosters students looking at what's the x-axis, what's the y-axis, the x-axis, what's the y-axis? Is that more than what we have in Colorado? More precipitation, let's see, it's in millimeters per year, 600, and we've got several months with hundreds of millimeters of rainfall, so tens of centimeters. So yes, by and large, it is more than what we have in Colorado. And I can see this sort of, wow, it really drops off here in the dry season. It's almost 0 in certain years. And I can see the pattern. So now, if my next question is, well, what if I click in Southwest Algeria? I'm going to have based on our discussion in class yesterday, right? We know about the ecoregion there. It's the Sahara Desert, right? So we have whole months of the year, hopefully the students will say, we have whole months of the year with no precipitation at all. And if you go to the map, of course, that bears it out. Yes, your hypothesis is confirmed. And so therefore, what kind of ecoregion is supported? What kind of agriculture is supported? What kind of settlement of human population is in Algeria, right? It's mostly clustered on the wet side, which is the northern rim over by the Mediterranean, correct? So what about, other places maybe a little closer to home? What if I click in Southeast Texas? In Southeast Texas, my hypothesis is there's going to be certain spikes in August, and we could have a chat about this in the chat box, but as you can see here, there's certain spikes because of the big tropical storms and hurricanes that have roared through there, unfortunately, for the residents, periodically in August and September of many years. So you can see not only the trend, but you can see the spikes from those tropical storms. Many of these tools that I'm introducing today have a sort of what I call a level 1, where you're looking at it in a web browser and you're asking inquiry-driven questions. The students are answering. You can write this up in a short lesson. We've got some lessons that I'll talk about already that are pre-made if you want to use those. But the point is, you've got some data and some interactivity at your fingertips. But level 2, which we could talk about maybe in a future webinar, for example, most of these tools today, there's what I call a level 2, if you want to dig deeper. In this case, look in the lower left here. You can download this data into a CSV. And then once you have it in a CSV, you could actually bring it into ArcGIS Online, and then you could add other layers. Population density. You could bring this into Excel, right, and do some analysis. You could bring it into a statistical package for those of you that are teaching secondary, et cetera. So the Water Balance app, I think, is a very easy to use, but yet very powerful tool looking at changes over space and time, which of course you and I love, right? Anything to do with change over space and time is such an indication of the Earth as a dynamic planet. Another low-hanging fruit kind of a tool is this Wayback imagery app. So this is another part of the Living Atlas of the World. And if I open the Wayback imagery, you've got literally, folks, petabytes of satellite imagery, in this case, at your fingertips. How could I use that to teach about water? Well, for example, the Wayback imagery opens, all these maps have a default opening. Some of them are global, some of them are Colorado, some of them are USA. Depends on the mapping application. But in this case, you've got a swipe capability in the upper left. So if you click on that swipe capability, you're going to have, like you've seen a lot of web maps these days, you've got this interactive sort of a big squeegee that you can roll across the map like this. So in this case, I'm saying, oh, on the left side, I want 2014 imagery. On the right side, I want 2021 imagery, and I'm going to look at just 7 years of change. And again, what's where, why is it there, and why should we care? Oh, this is a semi-arid area. How do we know that? Let's read some clues on the landscape. What do these cliffs look like? Are there any trees there? Okay, so we're starting to establish that this is a semi-arid area. Some of you actually probably know where this is already. But just in the case of 7 years, there's massive amounts of urban sprawl. So what? So what if there's urban sprawl? Okay, well, where's the water going to come from, right? For domestic, commercial, and industrial use. In this case, like a lot of cities, right, they've actually mined out most of their groundwater that they've had in the past, and so they're relying on a lot of surface water. And again, some of you probably know what I'm going to do next. I'm going to pan over to the east here, and if I pan over in Las Vegas, thank you very much, Priscilla, in Las Vegas over to the east, right, I'm going to look at Lake Mead, which is, of course, as you know, a reservoir. And if with the same tool, I'm going to say, oh, well, gosh, with just this one tool, I've got multiple scales that I can analyze, multiple years. I can look at changes in my own neighborhood. But more importantly, let's pan over here to Lake Mead. And just with this one tool alone, you can probably see where I'm going next, right? And that is, gosh, I can look at glacial change with this one tool. I can look at coastal erosion. I can look at agricultural expansion in Saudi Arabia or in the Midwestern USA. With center pivot irrigation. I can look at the construction of the Three Gorges Dam in China and other changes to river systems. And again, why should we care about those things? Well, you can analyze all of those things with this one single Wayback imagery tool. And germane to our discussion right now is, okay, I'm going to pan over here to Lake Mead, and just, again, with this one tool, I'm going to see that, okay, in 2014, this was the lake level. And in 2021, this was the lake level. So if I just use that swipe tool again, I'm going to see that, oh my goodness gracious, the water is declining. Okay, so what is the resiliency plan? What's the sustainability plan for Las Vegas, Phoenix, Riyadh, other places in arid or semi-arid areas around the world, and even not so arid areas, right? Atlanta had a 30-day supply of water 5 years ago, and of course you and I as educators were like, what's wrong with this picture? What's wrong with the fact that not very many people seem to be concerned that there was a 30-day supply where there were 6 million people living? So even in wetter areas, there's water issues, right? Fascinating. So yeah, Sarah, there are historical images. They're not part of the Wayback imagery, but that's the power of level 2. So just like the water balance app, if I, in the upper left here, there's a little cloud with a couple layers. And if I sign in to ArcGIS Online, which you all have access to, and we'll talk about that more later on in this webinar, then you can take the data into ArcGIS Online, these images, and then you can add further back Landsat imagery, historical digital aerial photos from the USGS and from your own state organization, and look at changes even farther back. Oh my gosh. So just with this one tool, you've got a level 1, which is right here, and then level 2, you can dig deeper. Fascinating. And I wish we could spend the whole hour on that tool alone.